All right, so our key ratios are going to look like this. I'm going to actually change it around a little bit too. So there's theta again. This would be my opposite, my adjacent, and my hypotenuse. The first trick in all of these trig problems will always be figure out what angle you're looking at and then label the three sides, opposite, adjacent, hypotenuse. And I always do them in that order because I always start with, I know where my angle is, go across the triangle to get the opposite. The other leg, the other side that's attached to the right angle is the adjacent, and then I do my hypotenuse last. However works best for you, stick with that. Now we talked about the ratios of these sides. So if we do the opposite divided by the hypotenuse, that's ratio. That ratio is referred to as the sine of the angle. We abbreviate it as sin, S-I-N. That's the sine. And then we say what angle we're looking at. So for the given angle, whatever it might be, let's say for argument's sake it's 30 degrees. So for, say, 30 degrees, there is a known ratio of the opposite to the hypotenuse. Now, you guys kind of remember from the special right triangles, if I told you this was 4 units, the hypotenuse is double that for a 30, 60, 90. So 4 to 8 would be reduced to a ratio of 1 to 2.
Wait, where did you get that? Yeah, I'm so confused. It's just like phone numbers.
Okay. Let me restate what I said and slow it down a bit. Let's say this was 30 degrees, right?
Yeah.
You guys remember from special right triangles that whatever length this is, again, let's say it was 4 units. You know the rule, right?
Oh,
The hypotenuse is double that.
those aren't memorized.
Though they should have been. They were a couple of chapters back. They were memorized.
Yeah. No, it was one of those you cram right before you take it.
I,
Can we like put a poster up on the board?
right. So you guys can remember that. If this is 4, that would be 8. So the ratio is 1 to 2. Now, the important takeaway, guys, is not so much this. That's where you got to really be focusing right now.
What does S-I-N-E?
That's sine. That's the name of this. We write S-I-N, just the first 3 letters of the word sine. But that's what it really is. Well, no, because we've got lots of these. There's a lot of trig ratios.
Theta or what?
Theta, yeah, we use a Greek letter for it.
But, so what's the sign?
Sine is a word, not a letter. What's up?
Why do you like when you wrote sine 30 degrees for 1 half?
Yeah.
You have to write sine for it.
Yeah. Yeah, 30 degrees is not equal to half. It equals 30. But the ratio of the opposite to the hypotenuse at 30 degrees is a ratio of 1 to 2. The other 2 trig ratios we're going to work with are the opposite to the hypotenuse, and that gets called cosine.
You mean the adjacent to that?
That's what I said, adjacent to the hypotenuse, cosine. And opposite to adjacent, which is the tangent.
Wait, isn't that the same exact symbol as the...
They're all referencing the same angle.
Okay.
All of these ratios are find the angle, and then for that known angle, say 30 degrees. It's a good angle. So say for 30 degrees, there's going to be some fraction, some ratio that connects the adjacent to the hypotenuse, that connects the opposite to the adjacent, and that connects the opposite to the hypotenuse. Those are known ratios. Now, the advantage for you guys is somebody's already done all the work to figure out every single one of those ratios. If your calculator has a sine, cosine, tangent button, which will look like sin, sin, cos, cos, or tan, tan, they've already put all of those ratios in your calculator. They also have, you can print out, and I will have copies handy, a full list of all the trig ratios available. So you can always just look those things up online, or you can take your trig sheet out and say, okay, I need to figure this one out. What's this? What's that? I can look them up now. There's no calculation involved in any of this stuff. You just write it down. So for example, we usually write sine of 30 degrees is 0.5. Cosine of 30 degrees, we can look up the ratio for every triangle where it's 30 degrees, a over h, and I'm going to flake out on the actual decimal now because I'm a little rusty, is 0.867. And the tangent of 30 degrees, that known ratio, if it's 30 degrees, the ratio of these two sides will always be
0.577.
exactly. Now, if you have a scientific calculator, this section's a little bit easier, but you can get by without it. You can still use your standard 4 functions, the ones that I keep around. You just have to have a trig table with you. And I will always make sure you have a trig table for tests and quizzes. And that's a complete list of every sine and cosine and tangent for every angle from 0 to 90 degrees. So you don't need to have the up and coming calculator. You do need, however, to memorize those guys. What are the decimals for? When we get into actually solving the triangles, what those ratios are will become more important. We'll do stuff with them. We'll put them in proportions, actually. But our second objective today, first one was to memorize the sides. Second one is to memorize these three things. And the last thing that goes with this now is this mnemonic device that we tend to use a lot in this chapter. SOHCAHTOA. It's a nonsense word that's not too hard to remember. And if you ever talk to people who have studied math, they will almost all remember this word. And what it does is it links sine, opposite over hypotenuse, cosine, adjacent over hypotenuse, tangent, opposite over adjacent. And it puts them all together in one spot.